Okay, YouTube, in this video we're just going to look at writing a transformation of a function given some initial parent function here. So let's read through this problem here. It says let the graph of g be a horizontal stretch by a factor of 3 followed by a translation 6 units to the right of the graph of f of x equals the cube root of x. So it says write a rule for g. And so what I want to start with is essentially this. We know that f of x initially is equal to the cube root of x. And so what they're doing is they're telling us with respect to g of x is really like f of x, but what we want to do is have a horizontal stretch by a factor of 3 followed by a translation 6 units to the right of the graph of this here. So what I'm going to do is I'm going to say, well, really what we have, we'll not write it in terms of a cube root, let's write it in terms of f of x, is we have a situation where I'm going to take this and I'm going to shift it 6 units to the right, so I have x minus 6, and what we want to also have, this is the weird part of this situation, is we want to have a horizontal stretch by a factor of 3. So we're going to have to take this x-like quantity in here times a third. So we get this function right here. And essentially what we're saying is, well, then g of x would really have to be this function right here where we have a horizontal stretch by a factor of 3 and we've gone right 6 units. So what I'm going to do is actually plug in this 1/3 x minus 6 into f of x. And so we'd say, well, what is f of, just curious, f of 1/3 x minus 6? And so because f of x is the cube root of x, this means that everywhere I see an x, I can take this out and I can instead plug in 1/3 x minus 6. Now, if you're thinking, hey, is there any way I could distribute the 1/3 in there? Certainly you may feel free to do so. We could say this is 1/3 x minus a third of 6, which is 2 here, but we would get our g of x function here that would align with what we wanted to do here, which was stretch it by a factor of 3 and shift it right 6. Cheers.